Can you imagine yourself living in a country with a much drier or a much wetter climate in just a few decades? For some of you, this might be even pleasant if you get, say, yesterday's wonderful weather here in Paris more often. But can you imagine France having drier seasons and what stress this would mean for its multi-million wine industry? My name is Nikos, and I'm trying at the University of Athens to address whether we can have such abrupt regional climate changes around the corner in the future. Because we have indications that such sudden changes have occurred in the past, and that these changes might be associated with the jet stream. Now, the jet stream is a huge river of air flowing 10 kilometers above our heads. It's flowing from the west to the east, and it's very important for the climate because it acts as a highway for weather storms. One of the reasons that Britain, for example, gets so much rain is that the jet stream goes across the island, so it brings storm after storm, dropping all the moisture that the storms have gained over the Atlantic. So where the jet stream is, the position of the jet stream and what its shape is, affects the regional climate, but also through its interaction with the various other climate components, it can also affect the global climate as well. Then the questions that come naturally into someone's mind is that, well, is the position of the jet stream fixed? Or, for example, in a warmer world, will it shift to a new position? And if it does, is this going to be gradual, or is the change going to be sudden? And these are the exact questions that my project would like to address. So you can take an approach and say that I'm going to use a global climate model, which is a computer model with all the known processes. And here it is in all its glory. And just by looking at it, you might think that maybe that's not such a good idea. Because first, it's computationally expensive, and to answer questions like this would take years. And second, because we're interested in this little box here. So with all the processes around, it would be like looking for a needle in a haystack. So we have decided to follow a different approach and just focus on the atmosphere dynamics and ask the question, well, if I just take into account the atmosphere dynamics, will I be able to get multiple states for the jet, and what's their sensitivity? So in other words, it would be like, let's find first the needle in the barn, if it is a needle, and then let's add the hay together. So in other words, let's then add the other processes in the climate model together. Now, even this is a difficult task to ask the question how the motions in the atmosphere are organized into the jet stream, because these motions are highly complex and chaotic. So the approach that we have followed is not to focus on the individual's motions themselves, but try to figure out equations that govern the statistics of these motions. And this is what we have done. And if we find solutions for these equations, then the solutions are going to tell us where the jet stream is. And once we have that, we can study its characteristics and also its sensitivity to, say, in a warmer world. So once we have this information, we will help people running global climate models know whether there's a surprise around the corner and why that might be regarding at least the jet stream, and we will be in a much better position regarding predictability skills and risk assessment for possible future changes. And with that, I would like to thank you for your attention.
Any preliminary result or intuition of yours on whether this is going one way or the other?
Well,
we won't tell. You're just videotaped and live tweeted.
Yes and no. Right now we have an idealized model, which is a huge planet. and this planet can accommodate more than one jet. So what we have found is that as you, say, warm up the planet, then instead of having 3 jets, you turn out having 2 jets, which is a large change for the planet. And now we're trying to sort of going into a more realistic Earth-like situation where we have 1 jet and see if its position is shifted or not.